So this is a number line representing integers. So these are points which are numbers, which are representing all the integers. Both sides I have an arrow depicting that they are infinite in both the directions. So these are the infinite numbers which are integers. Now, can you find an integer between 1 and 2? Clearly not. After 1, the next integer is 2. So there is no integer between 1 and 2. But what if I ask this same question when the number line represents rational numbers? So if I have a number line that is representing rational numbers and I ask you whether there is any number between 1 and 2, then well, yes, you have rational numbers. We've seen fractions are numbers which can be between two numbers. So I have numbers here between any two numbers which can be written as fractions, and these fractions are nothing but rational numbers. So now I want to find a number between 1 and 2. What would that number be? So what about the midpoint of 1 and 2? So this distance is 1. Midpoint would be half of this distance. So if I want to find the midpoint of this number, that is the midpoint between these two numbers, what would that be? Simply 1 plus 2 divided by 2. That would be the midpoint of 1 and 2. That is, you add 1 and 2 and divide it by 2. So this gives me 3 by 2. So 3 by 2 actually represents this number, which is the midpoint of 1 and 2, which is 3 by 2. Now, again, applying midpoint, I can find a number between 1 and 3 by 2, which is midway between 1 and 3 by 2. And similarly, I can also find a number midway between 3 by 2 and 2, using the midpoint. So let's find a number between 1 and 3 by 2. So that would be 1 plus 3 by 2 by 2. So you add these two numbers, 1 plus 3 by 2, and you divide it by 2. You get the mid value of these two numbers. So this would be, you have divided by 2 here. What I need to solve is 1 plus 3 by 2. Taking LCM, I get 2 plus 3 by 2, which is 5 by 4. So I get a number 5 by 4, which is the mid number between 1 and 3 by 2. So I get this 5 by 4. So which is this number here? Between 1 and 3 by 2. So what I actually see is that I wanted to find one number between 1 and 2, but I've actually found 2. Similarly, I can find 3 numbers. How? I can find a number midway between 3 by 2 and 2 also. Then I can keep on finding a number midway between 1 and 5 by 4 also. Similarly, I can find a number which is midway between 5 by 4 and 3 by 2 also. And so on. So, not just one number or two numbers, I can find many numbers between 1 and 2. And what you can see is that we know that number 2 is greater than 1, and this number 5 by 4 is also greater than 1. Further, this number 3 by 2 is greater than 5 by 4 and less than 2. So you found two numbers between 1 and 2 such that 3 by 2 is greater than 5 by 4. So whenever you have these two numbers, two integers, two rational numbers, which is A and B, and you want to find a rational number between these two numbers, all you need to do is add these two numbers, A plus B, and divide them by 2. This would give you a number here, which is A plus B by 2. Now this number clearly would be greater than A, but would be less than number B. This is what you get. Now another way is, now if I want to find say 4 numbers between 1 and 2, what I do is I divide this unit length into 5 equal parts. 1, 2, 3, 4, 5. I have divided this unit length into 5 equal parts. Now each part tells me this is 1 by 5, this would be 2 by 5, this would be 3 by 5, this would be 4 by 5. So each division is moving that number of times forward, 1 by 5, 2 by 5, 3 by 5, 4 by 5, because I divided this unit length into 5 equal parts. So I get this. Now if I want to write numbers between 1 and 2, what would that number be? Now this number is not 1 by 5. This number is actually 1 plus 1 by 5. This number, we know till here we have the length as 1. Now what would this number be? This is 1 plus this part which is 1 by 5. So this number is actually 1 plus 1 by 5, or you can represent this as a mixed number 1 by 5. Similarly, this number here would be 1 plus 2 by 5, which is 1 2 by 5. So this is 1 by 5. This is 1 2 by 5. This is 1 3 by 5. And this number is 1 4 by 5. So I can say that 1 by 5 is greater than 1, then 1 2 by 5, then we have 1 3 by 5, then I'll have 1 4 by 5, which would be greater than all these numbers, and this 1 4 by 5 is actually less than 2. Now I know how to convert these mixed numbers back to fractions. So I can convert this mixed number into an improper fraction. I have 1 here. This would be 1 into 5, which is 5, plus 1, 6. 6 by 5. This would be 5 plus 2, which is 7 by 5. Similarly, this is 8 by 5. This is 9 by 5. And this is number 2, which is actually 10 by 5, which gives me 2. So now you can see that between 1 and 2, you have got 1, 2, 3, 4. You've got 4 rational numbers between 1 and 2. So this is what I get, 4 rational numbers between 1 and 2. Now I had started with making 5 such divisions between 1 and 2. I could have also made 10 divisions between 1 and 2. That would have given me 9 numbers between 1 and 2. Similarly, 100 divisions would actually give me 99 numbers between these two numbers. So what I can see is that I can keep on dividing this unit length into as many numbers as I want. I can divide it into 1000 divisions, I can make 10,000 divisions here, and so on. And I can keep getting rational numbers between 1 and 2. So there are infinite numbers between 1 and 2. There are infinite rational numbers between 1 and 2. Because I can divide this unit length into infinite number of parts. I can make small divisions, very small divisions, dividing this line or dividing this unit length into very small number of parts. So I can get infinite number of rational numbers. Now let's say you want to insert rational numbers between these two numbers. Now I don't know where this number lies on the number line. I don't know where this number is on the number line. All I'm interested is in finding a rational number, finding 3 rational numbers between these two numbers. So what you can do is, easier way is take LCM and make the denominators the same. That's the easiest way which you can follow. So what I'll do is, LCM of 9 and 5 would be again 45. 9 5s are 45. So what I'll do is, I'll make the denominators same, which is 45. I multiply 9 by 5. If I'm multiplying the denominator, I have to multiply the numerator too. So 5 by 9, when multiplied by 5, both the numerator and denominator when multiplied by 5, gives me 25 by 45. So I get this. Now I have 4 by 5. I multiply both the numerator and denominator by 9, which gives me 36 by 45. Now all the numbers between 25 by 45 and 36 by 45 are the rational numbers that lie between these two rational numbers. So I have 5 by 9 here. I can write 4 by 5 here. Since I wanted just 3 rational numbers, I can pick any rational number starting from 25 to 36. So it can be 26 by 45, then 27 by 45, 28 by 45, and so on. I just wanted 3, so I picked these 3 numbers. You can move on till 35 by 45. So all till 35 by 45, all numbers are less than this 4 by 5, which is actually 36 by 45. So that's how you can insert rational numbers between two numbers. So now, I want to insert one rational number between these two numbers. Can you do that now? Again, what I need to do is make the numbers the same. So I have 2 by 9 here. I have 3 by 8 here. I multiply the numerator and denominator by the same number. LCM of 9 and 8 is 72. So I multiply this by 8. And I multiply the numerator also by 8. Similarly, for this number, I multiply the denominator by 9 and the numerator 2 by 9. What do I get? Here I get 16 by 72. And here I get 27 by 72. So all the numbers between 16 by 72 and 27 by 72 can be written to represent a number between these two numbers. So I can either write 20 by 72, I can write 25 by 72. So all these numbers, 17 by 72, all these numbers lie between 2 by 9 and 3 by 8. So we've seen how we can insert rational numbers between two integers. Not just between two integers, we can insert rational numbers between two rational numbers also. And there are infinite rational numbers between any two numbers.